This is PreCalculus 12, Chapter 3.3. We're continuing our look at transforming graphs. So this time we're looking at scaling, and this is A and B. So it's not just -1, we're looking at any real value for A and B. Scaling can mean stretching or compressing, depending on the value. So we have y equals A times f of x. If the absolute value of A is less than 1, we have a vertical compression. If the absolute value of A is greater than 1, then we have a vertical stretch. If we're doing a vertical stretch, we're not doing anything to the horizontal. So the only equation we have is y prime equals AY. This is our A. So we have y prime equals 2y. So we're doubling the y values. Y is -1, so it becomes -2. Y is 1, so it becomes 2. Y is 2, so it becomes 4. Y is -2, so it becomes -4. And we join the key points smoothly, as smoothly as we can. And we should label our graph f of x and g of x. Let's look at the domain and range. The domain starts at 1, 2, 3, 4, so that's -4. And it goes to 1, 2, 3. Our range starts at -2 and goes to 2. So just like before, we can do the transformation on just the range. The domain remains the same, -4 to 3, and -2 times 2. We don't have to swap this time because A is positive. If A was negative, we would have to do the swap. -2 times 2 is -4, and 2 times 2 is 4. So in general, the domain is unchanged, and the range is multiplied by A. Let's look at y equals f of b times x. If the absolute value of b is less than 1, we have a horizontal stretch. If the absolute value of b is greater than 1, then we have a horizontal compression. This is opposite of the vertical because we have a slightly different formula. We have x prime equals x over b. So we're dividing by b. Here's our b. 0.5 is a half. And this is easier dealing with this as a fraction. We have x over 1/2. And because we're dividing by a fraction, we want to take the reciprocal. That's 2. And we want to multiply it by the numerator. So we have 2x. So we're doubling the x values. This is 2, it becomes 4. This is 1, it becomes 2. This is -1, it becomes -2. And since we're dealing with horizontal, the vertical remains unchanged. We draw smooth lines between our key points. If this was a curve, you would draw curves. So let's look at our domain. We have -1 to 2. And our range goes from -3 to 2. And the range doesn't change, so let's write that down. And the domain gets multiplied by 2. Again, this is positive. We don't need to swap. -1 times 2 is -2. And 2 times 2 is 4. We check with the graph. We have -2, and we have 4. So, in general, the domain is divided by b, range is unchanged. For a slightly more difficult problem, we can combine horizontal and vertical scaling in the same graph. This is our A, this is our B. So we have x prime equals x over -2. We have y prime equals -1.5 times y. Doesn't matter which one you do first, but I'm just going to stick with the x. So -1 divided by -2, that's positive 1/2. Let's look at our next point and draw the corresponding points. This one is 2. We're dividing by -2. That gives us -1. And here we have 3 divided by -2. That's -3/2. So we've just done the horizontal. Now we need to do the vertical. This is 3 times -1/2. That becomes -4.5. 1, 2, 3, 4.5. And this one is 1 times -1.5 is -1.5. And we have 0, and that remains at 0. So we connect the points. And we label our graph. So this time we'll have to modify the domain and range of the f function. So we have -1, and it goes to 3. We have 0, and it goes to 3 as well. So we take -1 divided by -2, that gives us positive half. Because b is negative, we have to swap. And we take a look at 3 divided by -2, that's -3/2. And we look at y. 0 times -1.5 is still 0. And it's negative, so we're going to swap. And 3 times -1.5 is -4.5. If we want to be precise, we say this is -9/2. So let's recap. The easiest way to scale a function, plot the function f of x, if not given. Then we scale the key points or grid points. Then copy the curves between key points. A line is a curve, but a curve is not a line. So a line is just a special type of curve that happens to be straight. And let's recall our functions. If we're transforming from pre-image to image, that means we're going x prime equals x over b, and y prime equals ay. However, if we're doing the backwards problem, we're going from image to pre-image. That means we need to do some algebra. So bx prime equals x. Here we divide both sides by a, so we have y prime divided by a equals y. So the point on the image is 5, 2, and the transform is a vertical compression of 3 and a horizontal stretch of 2. Find the pre-image point. This is our backwards problem. So the horizontal stretch is 2, And because it's a stretch, we know that b has to be less than 1, so we do 1 over 2. b equals 1 over 2. And our a, we're told that this is a compression. So that must mean this needs to be less than 1. So a really needs to be 1/3. So go by the words here and adjust the number that you're given accordingly. So now we use this formula, x equals 1/2 times x prime, that's 5, y equals, and we're looking for y prime, that's 2, divided by a, which is 1/3. Now we're going to multiply by the reciprocal. This is 3 times 2, that's 6. And are we done? No. We're supposed to find a point. This is not a point. So we write 5 over 2 in brackets and 6. And box our answer. The pre-image has a point P, 10, 6. The image has a corresponding point. P prime is 5, 2. Determine A and B. So this is almost determining the equation. And again, these problems can be solved by inspection, but practice using algebra on the easy questions. That way you'll be able to use them on the harder question. So we just use either formula. Doesn't matter which formula we use, we should come up with the same answer. So I'm just going to do some algebra on this. B equals x over x prime. So we have x over x prime. That's 10 over 5. And y prime equals ay. So a equals y prime over y. So y prime is 2 and y is 6. And we can simplify this to 1/3. So we found our b and our a. However, this should be reduced. This is just 2. Box this one and scratch this one off. And if we needed to write this as an equation, we would say g of x equals 1/3 f of 2x. And that completes this lesson.